Myself, Dr. K. Hemalatha, Assistant Professor, Department of Computer Science and Engineering, Artificial Intelligence from MITS. Today, the topic is fractional knapsack problem using greedy method. The flow of presentation is like this: greedy method, components of greedy algorithm, pseudocode for greedy algorithm, applications, limitations, fractional knapsack problem, the steps to be followed, and the example with solution. What is greedy method? Greedy method is a problem solving strategy which uses choices to get best result at that moment. This greedy method works on the property of greedy choice property, optimal substructure. What is called greedy choice property? In greedy choice property, we will choose the local optimal choice. We hope that it will lead to the global optimal solution. That means for any problem, we will divide the problem into subproblems and we will find out the local optimal choice. So we think that this solution may lead to the global solution. This property is called greedy choice property. Next one is optimal substructure. What is called optimal substructure? The substructure consists of optimal subsolutions. So already we said the problem is divided into subproblems. Each subproblem will contain one optimal solution. All these optimal solutions comes into this optimal substructure. So what are the components of greedy algorithm? Greedy algorithm have the following components. They are candidate set, feasible solution, objective function, optimal solution. Here, what is the candidate set? The candidate set is a solution created from the set. So from this set only, we are going to create the solution or develop the solution. So that set is called as candidate set. What is feasible solution? Feasible solution is the subset which satisfies the constraints. Each problem will have some constraints. The constraints which is satisfied by the solution is called feasible solution. So what is our objective function? We already told some constraints. What are that constraints will be considered the objective function. What is the objective function means? This objective function is to create the feasible solution. Here, the objective function can be maximize something or minimize something. For example, mainly we focus to reduce time, that is minimization. We focus on maximizing cost, that is called maximizing objective function. Finally, we will have one optimal solution, that is called final solution. How we are getting this optimal solution? We are creating feasible solutions to the subproblems. These feasible solutions are satisfying the objective function. So based on all the feasible solutions we got from the subproblems, finally we will get one solution, that is called optimal solution. So all this terminology is very important to understand about the greedy algorithm. So coming to the pseudocode. Pseudocode for greedy algorithm. So here we can observe the pseudocode. So we have solution. Initially the solution set will be 0. For each iteration, here n is the number of elements in the candidate set. For each element, we are applying the function select. So all elements are not going to select. If it is feasible solution, then only we are adding it to the solution set. Here we given the constraint feasible of solution X. So whether the solution is feasible or not. So like that, we are selecting each and every solution which are feasible only. Once we get all the solutions, we are going to merge it. So here we take an union function. So after that, we are getting the solution. This will be the optimal solution. So this is the pseudocode for greedy algorithm. Next, applications of greedy algorithm. Greedy algorithm is a easier algorithm to describe. Then this greedy algorithm perform better than other algorithms. So we already know no one algorithm will perform better for all the cases. This algorithm work for more cases better, but not in all cases. Next, coming to the limitations of greedy algorithm. So there are limitations for this greedy algorithm also. This algorithm decides decisions. So based on the information available at this current phase, but it won't consider the broader problem. So this may lead, for example, we considered one solution is the global solution based on the greedy algorithm, but in some cases it may not be the global solution. It may be some local solution. This is the main limitation in greedy algorithm. So it may not give a correct solution. That means the optimal solution or best solution in every problem. This is the limitations of greedy algorithm. Next, we will look into the problem fractional knapsack. So coming to the problem statement, what is fractional knapsack? So there will be a set of items. Let it be I1, I2, so on, n items, let it be In, and weights corresponding to the n items W1, W2, so on, Wn. And these weights contain some values called V1, V2, so on, Vn. Here we have some weight W. So here the problem itself saying that fractional knapsack problem. Knapsack means a bag. Here our objective is we have to fill the knapsack with items I1 to In. The items consist of weights W1, W2, so on, Wn. Each item consists of values V1, V2. And the maximum weight limit of the knapsack is W. Here our objective is to fill the knapsack bag with the items so that the weight limit should not be exceeded and we have to get the maximum benefit. So here our objective is maximizing the benefit. Here the name itself told that fractional knapsack problem. Here the fractional part of the item is allowed to obtain the objective of the problem. This is called the fractional knapsack problem objective. So the steps to be followed. So what are the steps to be followed? First, we have to calculate the value per weight for each item. So already values V1, V2, so on, Vn are given and W1, so on, Wn are given. Now we have to calculate the value per weight for each item. The formula is like value by weight. Second one, we have to sort the value density in descending order. After calculating the value density per each item, next we have to sort the items based on the value density so that higher value density item should be in first. So based on the priority of value density, we have to consider the items to fill the knapsack bag. Every time we have to pick one item and we have to put into the knapsack. So that finally we have to achieve the objective. These are the steps to be followed. After that, what we have to do? So these are the some formulas related to the knapsack total value, total weight, like that. So based on the formulas only, we are going to calculate the total value, total weight. So all this will be illustrated with the help of an example. So let us see the example. So here I am giving one example. For example, the maximum weight is 16. So here some items are given. Here 6 items are given. Their corresponding weights and values are also given. So we have to follow the steps to solve this problem. So what is the initial step? So we have to calculate the value density. So using the formula value by weight. So I calculated value density using the formula. So these are the values of the value density I got for the items. So after this, what is the next step? We have to sort the items based on the value density. That means it should be in descending order. Now we are writing the all items in the descending order. So this is the descending order. If you observe here, You can see highest value density items are in front, and later smallest values are there. Here you can observe the items numbers also changed because this value density is corresponding to the item 5. So after arranging this in descending order, next we have to go for the filling of knapsack. So we have to fill the knapsack? We have two constraints. One is we should not exceed the maximum weight. So here I have a empty knapsack which contains of items, weights, value, total weight, benefit. Now I have to fill this knapsack with the items here one by one. Let's see how to fill the knapsack. So initially, what is the total weight in knapsack? It is empty. After that, what we have to do? So we have to take care of the constraint. The weight plus the total weight should not exceed the maximum capacity. Now, we are considering the first item because the value density of first item is high. The item number is 5. So we are considering the item 5 and we have to fill this knapsack with the item 5. So we will fill the knapsack with item 5. So here you can observe the knapsack contains item 5 with weight 1, value 3. The total weight is 1 because in the knapsack bag the item only is 5. The item 5 has weight 1 and value 3. So total weight is 1 and the benefit is 3. So next we have to enter the second item which is in the order next one, that is 6. So before that we have to check the constraint, it is satisfied or not. Here the constraint is satisfied because the total weight is 1 and it is less than 16 only. Now the total weight in knapsack is 1. Again you have to move to the next one, that is 6. The next item is item 6 which has the weight 3 and value 5. So we have to enter the item 6 in knapsack. So we entered the item 6 into the knapsack. Now you observe what is the total weight? 4. Why it is 4? Previously its weight is 1. Now we are adding item with weight 3. So totally now the weight is 4. What about the benefit? Previously benefit is 3. Now we are adding another item with benefit 5. So finally it is 8. That means you have to add the weight and you have to add the benefit also. So coming to the next item. So here again we have to check the constraint. What is the constraint? The total weight is 4 which is less than or equal to 16. Next we have to move for the next item and we have to add the next item into the knapsack. What is the next item? The next item is 4. The item 4 will be added into the knapsack. So we are adding 4 into the knapsack. Again we have to observe what is the total weight and benefit. Here total weight and benefit are the main. The total weight is 9. Why means because previously the weight is 4. Now we are adding the element with weight 5. So total it is 9 and the benefit is 16 because previously it is 8 and now it is 8. So 8 plus 8, 16. So again we have to check for the constraint whether it exceeds the maximum capacity of the knapsack or not. So now I am checking. So our total weight is 9 only, but our constraint is 16. So it is satisfied. So we have to repeat the same process for the next item. So what is the next item? The item is 1. So we have to add that one to the knapsack bag. Again you have to verify the total weight. The total weight is 15 and the benefit is 22. And again the constraint. The constraint is 15 less than or equal to 16. It is satisfied. It is not false. It is true only. So again you repeat the same procedure for the next item. So what is the next item? The next item is 3. So we are going to add that one to the knapsack. In this way only you have to very careful. So why? Here the item 3 weight is 3. So you already know what is the total weight in the knapsack, 15. If I add this item to the knapsack, then the total weight may become 18. But it violates the constraint. So instead of adding 3 weight, I have to add only 1. Here the fractional part comes. So that only it is called fractional knapsack. So we have to add only 1 weight instead of 3 to the knapsack. Okay, we will add that one. So along with the weight, what we have to consider means value density. Here we calculated value density. This value density is per unit only. That means 1 weight only. So this one is per weight 3. Value 1 is per weight 3. But value density is only for 1 weight. So if you want to add partial weight to the knapsack, you have to consider the value related to that partial weight only. So now we are going to add only 1 weight into the knapsack. So here you can observe in the knapsack only 1 weight is added. Instead of the total value 1, we given 0.33 because this value density is only for weight 1 because we don't need a entire 3 weight, because if we take entire weight 3, our constraint will not be satisfied and the knapsack weight will be exceeded more than 16, so that our objective function will not be satisfied. So we have to take only 1 weight. So if we take only weight 1, we should not add value 1 because this value 1 is corresponding to the weight 3. But we need only the value related to weight 1 only. That is called value density. So we added 0.33 in the knapsack bag instead of 1. Now we have to finalize the total weight. So previously it is 15. Now we added weight 1. So it is 16. Now the constraint is satisfied. The knapsack bag reached maximum capacity. And the benefit is 22.33. So this is the optimal solution for the fractional knapsack problem for this example. That means this table shows the optimal solution such that if we add these items, that means 5, 6, 4, 1, 3 in the knapsack, then our objective function will be satisfied. That means our capacity is equal to maximum capacity only. Then we got maximum benefit. So finally you can see the solution. The solution contains what are the items should be added in the knapsack. So this is the total weight. So we satisfied the maximum capacity constraint and we have the items 5, 6, 4, 1, 3. So this is the total benefit 22.33 and total weight. So this is the solution for our example. So this is about fractional knapsack problem and working. Thank you.